Hello, my name is Stian Broen and I'm the CEO at Broen Tech Solutions. Today I'm going to show you an open source project used for scheduling tasks called SAUTO. First of all, I want to show you where you can read more about this project. You can go to our webpage at broentech.no and go into our expertise, native applications, and the SAUTO article here. And now let's have a look at it. So at first I will just show you how it works and what you can do with it, and then I will talk a little bit about the source code after that. So let's run it. What you can see here is just an interface for testing and demonstrating the concept. And this is a pretty straightforward interface. As you can see, it contains 3 lights and one button that goes with each light that you can click on them like that to turn the light on and click on it again to turn it off. And now SAUTO is for doing tasks, for example turning these switches on, but it really can be anything, and scheduling when you want to do it. So by clicking on this SAUTO button, opens this dialog. And as you can see, there are 4 ways for defining a schedule. It's a timer, day, week, and calendar. And I will go through each of them first, and then we'll see how they work afterwards. So for the timer, clicking the timer will bring this dialog up. And to begin with, the simplest thing would be to say that, for example, I want at 8 o'clock this work task to happen. So at the center of the widget, basically just it's the hours of the day. So it represents when you want to do something. So this means that at 8 o'clock every day I want the red light to be turned on. Then you can choose the static. Now you're saying that every hour of the day I want this to happen, to turn on the red. And by adding this or changing the values of these dials, you can see how this will impact the scheduling of the tasks. So let's turn this hour down to 0, and let's say that for like every 20 minutes, then turn maybe off the red light. And the third option is to have something called a wavelet, which basically is if you have more than one task and you want to do them in sequence, you can define a period, for example, for let's say well, an hour, and this is basically just a sine function, as you can see. And at the top you can say which task you want to do, for example to turn the yellow light off, and valley you can, for example, turn it on again. And in the middle, in between, when it rises, you can do something else. and on its way down again you can do something else again. And you can also change the phase of this signal depending on when you want to start doing this. So and now let's have a look at day. When you define a day, you can see again this timeline, but slightly different from what we just saw. And now you can either add an interval or a single shot. So let's begin with the single shot. If you add a single shot, you get this arrow on the line, which you can drag on the timeline and drop it where at the time that you want. And you can also use these ones for setting it more precisely, 5 o'clock for example. If you right click it, you can define what you want to happen at this time. And you can keep adding this if you want to. So let's try to add an interval. This interval can be also dragged along on the timeline, and you can also drag on the sides to edit the length of the interval at each side here. For example, like that. Now if you right click in this interval, you get this one up again. And now we can say that within this interval you want to do something. Let's say, for example, like that. And let's look at the week, which is basically almost the same, only this time you can choose to do something at specific days. For example, you can say, I don't want to do anything on this, the Monday, Tuesday, Wednesday, Thursday, but on Friday I want to do something special. I want to actually have this interval. Like that, for example. And that will happen only on Fridays now, every month. And if you don't do anything else, then you see we have checked also for Saturday and Sunday. But if you keep those check buttons checked, it's going to look back into the specification of the day and kind of inherit that specification. And the last one is the calendar. And you can probably guess just by looking at it what it can do with this. You can specify now each date that you want to do something special. For example, August. And again, leaving this checked will simply just inherit the weeks. But clicking this will let you specify it. Now you can click each date to toggle them on or off. Leaving them white just means that nothing will happen. Leaving them purple like this will make them inherit. And if you hold shift and click them, you mark them. So you can mark any date you want to. And now you can add intervals for these. For example, like that. Clicking OK will put them into the dates, and clicking OK at the calendar will put them into the month, making it green like that. So that's what you can do with the GUI. And now we can try to see how it actually works. So let's do something simple to begin with. For example, very simple like this. We want to do something specific at 10 o'clock every day. And let's call this particular setting something like, for example, simple task. Okay. Now we see something new in our testing GUI. We see that this was created in a list. And you can also see in the tooltip that it represents a file. If you double click it, we can have a closer look at this file. We can see that the setting was stored as an XML file that can also be loaded. Let's make another. For example, let's make a sequenced interval this time. For example, we can say that every, or actually make it static, 10th second, turn the green light off. And let's call this green off interval, for example. And again, it's an XML file. You can see here, period, 10 seconds. The same things. Let's try to start it and see what happens. Actually, let's turn the green light on first, and then we start it. As you saw, it got turned off right away. And we see here in this GUI that something is timing downwards. Let's see what happens if we turn it on manually again. And when the triggers goes down, you can see that the task is actually performed every 10 seconds. And let's take it even one step further. Let's make yet another one. We can make another one for maybe we should have one also for turning the green light on. Like that. Green on interval. Let's start that one. And now this one. So as you can see, you can have as many of these schedules as you want. let's make another one. Now I want to do something like this, but not all day. I just want to do it in a particular interval. And this interval should start, let's put it like that. And in this interval, I want to keep on putting the yellow light on and off in sequence. Okay. Yellow at evening, for example. And let's kick it off. And now this may look a little weird because actually each half pi now equals one trigger interval, but we only put a task on two of those. So you will see that every other time this one is cooling down, it will put the yellow light on and off. And you can keep on making these settings. And I mean, for this video, I mean, it would be a boring video if I, for example, did something like this, because today is not Friday, so I would have to wait until Friday to see this actually starting to do something. But I guess by now you will understand how this works. So weak test like that. Let's look at the weak test XML file that was just created. It looks like this. We can try to start it. Yeah, here you can see that there is quite an amount of milliseconds until this interval is starting at all. So it's kind of is counting down towards that. But we will not wait because it's quite a long time until this. So just for showing you that you can do this, and it's going to keep starting to do this on the time interval that we specified, which was weak test, starting at 4 o'clock at night. All right. So we can see that when I start the application again, it will find back these files that we created, and to see, we can see that they are stored as files on a local drive. And just to show also how the interface actually got the task, you see here, how did they get there? Well, I just made it read this folder and see which files were there, and these are just empty files, so it was just going to grab every file and put them on the list. And yeah, but these files could actually contain something. I mean, it could be some specification on how to perform the tasks or something like that. And yes, so I think we've seen enough of the interface. Now let's have a quick look at the code. SAUTO widgets contains all these customized widgets, and SAUTO XML is doing the loading and the saving of the schedules, and each one of these are models that are defined in the SAUTO model. Here we can see it. And the most important class is actually the one doing performing the schedules is the SAUTO manager, which contains a list of SAUTOs. And a SAUTO is a class that handles one schedule, and this manager contains many of those. And as you can see, they just send lots of signals. And when this manager wants something to happen, it's going to send this signal. Now, you as a programmer can connect this signal to a slot in your class, or a signal if you want to, and do whatever you want depending on the content of these parameters. So it could be something more useful rather than turning a switch in an interface on and off. It could be, for example, this SAUTO library depends only on the Qt core, so this might as well just compile into maybe some embedded software, and it can receive the XML it needs from someplace else, for example a web service, and it can start to do something. It could be opening and closing maybe a door, or something else. It can be anything basically. And yeah, that's what I was going to show you. And all this stuff is open source. You can find it on GitHub, and it's on an LGPL license. So thank you for watching this video, and please let me know if you need any help using it, and also it would be very cool if you let me know if you get any use for this in your own projects. Happy coding!